I thought I'd do a quick video on hooking up an Arduino-based frequency counter to a traditional superhet radio kit, in this case the 5-watter. The 5-watter is a kit available from Kits and Parts. I'll include a link below. It's about $50 and it's a great fun build if you're interested in that sort of thing. It's a superhet radio which uses a SA602 for mixer, and the IF frequency in this radio is 16 megahertz. So this particular example covers the low end of the 40 meter band from about 7 megahertz to about 7.045 megahertz. I won't go into an explanation of the kit itself here. There are a great series of videos from K7QO, and he goes through the build in great detail and he explains how the various parts of the circuit work. It's a really good series. I learnt a lot from that, and I'll include a link below to that. This radio uses a VFO frequency of 23.04 megahertz and an intermediate frequency of 16 megahertz. So you can see there 23.04 minus 16 gives you the 7.04 megahertz frequency that the receiver listens to. In order to determine the current receive frequency, the VFO frequency is sampled and 16 megahertz is roughly 16 megahertz is subtracted. So you can see here I've got the actual VFO frequency down the bottom, 23.024.8, and then the resulting frequency that the receiver is listening on, which in this case is 7.027.2 and 2 and a bit. I've got a schematic for the 1-watter that I'll briefly show, just to show you where I'm kind of hooking in the VFO frequency. And you can see here on the schematic there's this place for a capacitor called CS. It's unpopulated on the board, and so it's a great place to tap in VFO circuit. Excuse the mess here, I've been soldering over the top of it, but the VFO circuit is here, and coming down here this is the 23.04 megahertz. You adjust it using a pot here, but that 23.04 megahertz signal flows down here, so you can tap into it right here. So that's the kit. I'll now sort of move on to the schematic for the frequency counter itself, and I can't claim originality for this. There's quite a few circuits out there on the internet that do an Arduino-based frequency counter, and I had to do a few little things differently just to get it working for me. But anyway, here's the schematic here, and I'll quickly walk through it if I can get this piece of paper to stand still. So as I said, the sampled VFO signal comes out of that CS link on the 1-watter, and it's fed into this buffer stage here. So this is a JFET buffer, uses a J310 JFET, and the purpose of that is that because it's a FET, it has a very high input impedance, and so ideally we want to affect the VFO signal as little as possible. So that high input impedance of the buffer ensures that the VFO itself is not unduly tasked by the sampling. So after the buffer, the signal is further amplified by a 2N3904 based amplifier. Ideally, what we need on the output is a signal in the 2 to 3 volt range in order to pass on to the next stage. So the next stage is a Schmidt trigger, 74HC14, and that basically turns the sine wave that I'm getting out of this part and the VFO into a nice clean square wave, which is then passed on to the next stage, which is a 74LS93 4-bit binary counter. Now the reason that we need to do this is because This signal here is 23 megahertz, and that's way too much for an Arduino running at 16 megahertz to count. So what I need to do is divide that signal by 8, and that resulting signal can be counted by the Arduino. So this divided by 8 signal is then passed into pin 11 of the ATMega 328. And this pin 11, is a special purpose external counter input that the library that I'm using to do the frequency counting uses. So rounding out the circuit itself is an LCD down the bottom here, and the LCD it uses an I2C backpack, and the advantage of that is I only need the SDA and SCL pins out of the ATMega, so it saves a whole pile of pins. So as you can see the results here. Let me just walk through the various pieces of the schematic that I mentioned. So this portion here is the buffer. There's the J310. Here's the signal coming in from the 1 watt. This is the 2N3904 and the amplifier. And then here is the Schmidt trigger, the 4-bit binary counter, and finally the Arduino, and obviously the LCD here. And if I could turn it around, the I2C backpack's actually on the reverse side of the LCD. So let's see the result here. I'm feeding a signal in from the signal generator here at 7.03300 megahertz. And so we should see as I tune up rather. So you can see there, here's the VFO frequency and here's the actual receive frequency, 7.033 and a little bit. Let's see if we can get that a bit closer. So there we go, almost spot on. Now the frequency counter itself, hang on a second, let me turn that down a little bit. The frequency counter itself isn't particularly accurate. There's the software, and I'll include a link to the software below, but the software has basically 3 sampling intervals that you can set. One's 1,000 milliseconds, 100 milliseconds, and 10 milliseconds. Obviously, the longer your sample period, the more accurate the frequency counting. So I've got this set to 100 milliseconds. If I set the sampling frequency too high, the display here doesn't really follow your tuning quickly enough. So anyway, that's that. Now let me just move to a different frequency here. Let's say let's go to 7.015 megahertz, and then let me tune down. Turn the speaker up again so we can hear it. There we go. So there, it's hard to get it exactly on. But anyway, I've been wanting to do this for some time. Hook up a digital display to a traditional superhet kit for a while. So this is the result. What I might do next is get this on the air and just tune around and then compare the frequency to my IC7610. See if there's any differences there. Anyway, that's all for now. Well, it's the middle of the day here, so the band's a bit quiet at the moment on 40 meters, so I've just been tuning around a bit every time I get a station, it fades away quickly. But anyway, it's been a bit of a fun project, the 5 watt and the frequency counter. It's like I said, it's been something I've been meaning to do for a while. But anyway, that's all for now.